So this is the second part, second video for the first homework and the first lesson. The first video was on adding terms, so we did sums like the following, where you have to go like 5a plus 2b minus 3a, so on, so on, so on, and then you have to simplify them. So you have to combine the like terms, the a's, and the like terms. And hopefully you're more confident at that now after watching the video. And after doing that, you should be able to do the problems on the worksheet. And then on the second part of the worksheet, there was stuff on multiplying terms together. So this is where you multiply algebraic terms and combine them. And I'm going to quickly go over this. This could be debated as easier, because it's more simpler to do, and you don't have to look for like terms. You can just bash everything together and multiply them all together, which makes it a bit easier, but the application can also be a lot harder. And like I said, with maths you really need to practice, and you really need to just practice makes perfect. Once you've got it down, you just work through example problems until you've mastered it, and then you can build up and keep on mastering it until you're very good at it. And I also, on the third part of the homework, which was the problem solving, I really encourage you to have a go at that. You may enjoy the problems, and some of them may be too hard, and I'm hoping they're going to be too hard. You're not, if you succeed and get every question right, you're not learning anything. You need, like, they're there to challenge, and they're to help you think. So a few of them may be doable, but I'm hoping not all of them will be doable, and you'll still have to think quite a bit to do them. So do not be discouraged if you can't do any of them. So yeah, I'm going to go over multiplying terms now. So say we've got a term 5a, and we've got another term 5a. When you multiply these two terms, you get 25a squared. I've got no idea where you are. This could be obvious to you, but this could also not be. So at the end, I'm hoping you'll be able to explain why this happens. But in the meantime, I'm just going to go through and start from the basics. So say we have a to the first. This is called the base. So that the letter a is the base, and the number is the exponent. So a to the first is a. A squared is equal to a times by a. So if we had 5 squared, this is equal to 5 times 5. And if we had a cubed, this is a times a times a. So we can see there's 3 a's and they're multiplied together. And you can think of just a being a to the 1, so the exponent, so let's just write this here. If we have a to the k is called the exponent, and the k means how many times it's multiplied by itself, and the a is called the base. So yeah, so we've got a to the first, that's just equal to a. A squared is a times by a, and a cubed is a times a times a. So a to the k basically means you take a times a times a, blah blah blah. And how many a's are multiplied by themselves? Well, the k says that. So there are k a's multiplied by itself. So for example, say we had 2 to the 4, and we say like 2 to the 4th power, and the power is the exponent. So there may be a lot of information in here, but I hope it makes sense. This equals 2 times 2 times 2 times 2, which equals 16. I'm just going to keep on giving examples and showing how this works until you've mastered it. Say we have 5 cubed, so we call this as cubed and squared. For powers above that, we don't have any special word, but when it's a power of 2, so a squared, a to the 2 power, we call it squared, and when it's a to the 3rd power, when the exponent is 3, we call it cubed. So 5 cubed is equal to 5 times 5 times 5, which equals 125. If you had trouble doing this sum, you can break it into a smaller sum. So 5 cubed is the same as taking 5 by 5 first and then multiplying it by 5, which equals the same as 125. So what is 5 times 5? Well, 5 times 5 is 25 times 5, and this sum is a bit easier to do. So you can say this is equal to 125. Well, what is 25? 25 is just 5 squared, because 5 times 5 is 5 squared, times by 5, and this is equal to 125. So we can see 5 to the 3rd power equals 5 to the 2nd power times 5 to the 1st power. We don't write the 1 as the exponent here, but it's taken as just to be there. It's to be there, but you don't write it. So you can decompose the power into smaller chunks. Say we had, for example, I'll do another example. So we had 2 to the 5, which is equal to 32. That took me a while. Well, we can say 32 is equal to 2 times 2 times 2 times 2 times 2. We can split that into 2 parts. We can say this is equal to 2 times 2 times 2 times by 2 times 2. So in the end, there is just 5 2's being multiplied together. But you can split them into chunks, and we split this into this chunk being, well, there is 3 2's, so this is 2 cubed. 2 to the 3rd times 2 to the 2nd. And look at these numbers here. In this example, we had, I'm going to write this in a different colour. We had our 3 here, and a 2 and a 1. We noticed 5 equals 2 plus 1. In this example, we had 2 to the 5th here. 5 equals 3 plus 2. So the exponents add up to make this 5. The exponent of the 3 and the 2 add up to make the 5. So I'm going to do a general example for A. Say we have A to the B multiplied by A to the C. I'm going to highlight this one here orange. That's not a nice colour combination. And this one here a redder colour. So we start off with A times A times A. And how many A's are there? Well, it's A to the B, so there are B A's here. There is B lots of A multiplied together. And we know there is B, and we can remember this B by highlighting this in orange here. So there is A times A times A, B times there. And then because we're multiplying this by a to the c. So there's a times a. Well, how many a's are here? There are c a's. And we can highlight this in a red colour here. Well, we've now got a lot of a's multiplied together. We've got CA's here, and over here we have BA's. So how many A's are there altogether? Well, there's B there and there's C there, so in total we have B plus CA's. How can we write this? Well, we can write this as A to the power of B plus C. Okay. And we can see that's that colour, and that's that colour there. I hope you can understand how we get this from. So we take B lots of A multiplied together, which is equal to A to the B, and then you multiply that by C lots of A multiplied together, and then you can write this in this form, and you can clearly see the total number of A's is B plus C. So we can say A to the B times A to the C is A to the B plus C. This is a rule in algebra. So this is quite an important fact. I'm going to write this out in nice and fancy down here because it's something you need to know. A to the B multiplied by A to the C is equivalent to A to the B plus C. It's so important, I'm going to highlight it with a rainbow colour here. And I hope you see where we got this from. So I did a quick derivation, or a proof. That just means to show how we got there. We showed how we came to this result. I'm going to do some examples now, just so you can get comfortable with this. Say we have 5 squared times 5 to the 8. We want to find what k is. So 5 squared times 5 to the 8 equals 5 to the k. Well, this is our problem. Find what k is. Find k. Well, we can use the rule of a to the b times a to the c is a to the b plus c, and a is 5, b is 2, and c is 8. So we can say, well, 5 squared times 5 to the 8, we know from our rule this is equal to 5 to the 10. So we can therefore say this symbol here, 3 dots like this, means therefore. That's some terminology you may need to use. Therefore, 10 equals k. We can see we're looking for k, and that's the power in the final result, and that's 10 there. Nice. So I'm going to do a few more examples for you to complete, and then I'm going to show you one more thing. So say we have, so this is questions for you. Question 1. What is 2 to the 5th times 2 to the 5th? Question 2. This is 2 to the 9 times by 2 to the 3rd. And I would like this just in the form of 2 to the power of something. So I don't want you to actually calculate the values of this because these are big numbers. Question 3. 3 times 3 to the 8. And this is a challenge question, this one. This is a very challenge question. So I would like to have a go at it. I'm going to write a quick note. So notice, before doing this problem, notice that 2 2 cubed equals to 8. This is the problem. Find 2 to the 5th times 8 squared, and I would like it in the form of 2 to the k. And so basically we're asking to find k. So if you want to pause the video and have a go at those, I'm going to answer the first few questions, and I'm going to leave the challenge one for you to think about, and in the next lesson we can discuss the solution to that. So for the first one, using our rule where we combine the exponents, we can say this is equal 2 to the 5 plus 5 equals 2 to the 10. For the second question, we combine the powers. 2 to the 9 plus 3 equals 2 to the 12. And, well, we don't write what the power of 1 is, or 3 is here, but we know there is a secret 1 there. So this is equal to 3 to the 9. And I'm going to leave you this challenge question to think of. After watching this video, you should hopefully be able to do some of the problems on the sheet, on the homework. There are some stuff I haven't went over in the video, but I would like to see how you handle that by yourself. So instead of a video, just looking at, by reading the homework sheet and reading my notes, see if you're able to answer those problems yourself. If you're not, that's totally fine. I'm just trialing something to see whether it's better to do a video plus notes for you or just notes. So if you could complete that homework by our next lesson, or not complete it, attempt it, because some of the problems are hard. I'm nowhere near expecting you to do them all. So if you could just have a look at that, and for next lesson have your answers ready for us to have a look at what you found out, that would be perfect.